So in problem 6 from the AP Calculus free response, it says consider the curve given by the equation 6xy equals 2 plus y cubed. We want to show that the derivative is 2y over y squared minus 2x. So this is going to involve implicit differentiation. On the left, we're going to need to use product rule. So if I take the derivative with respect to x, x will just go away. So we have 6y, and then we have 6x times dy dx. The 2 is a constant, that will go away. Y cubed becomes 3y squared times dy dx. Now, since we want to solve for dy dx, we want to get these two terms on the same side. So I have 3y squared dy dx minus 6x dy dx. Now this right here, these two terms both have dy dx, so we can factor that out. And so we have 3y squared minus 6x. So 6y over 3y squared minus 6x. This equals dy dx, but doesn't equal what we started with, and that's because we can take a 3 out of both the top and the bottom. So we're left with 2y or y squared minus 2x. And there we go. So there is part A. Part B, find the coordinates of a point at which the line tangent to the curve is horizontal. So if the line tangent is horizontal, that means the slope is 0. So that means dy dx equals 0. Now if that's true, then that means the numerator must be 0. So that means 0 equals 2y, which means y equals 0. Now we're going to plug that in to our original problem. So 6 times x times 0 equals 2 plus 0 cubed. So when we do that, we get 0 equals 2, which is false, which means no point exists. Because we started with the condition that slope was 0, we said that 2y had to equal 0, so y was 0, and by putting that back into the original problem, it produced a false statement. So that means no such point worked. Now we're asking the same question about if it's vertical. Now if it's vertical, that means then we have an undefined slope, and the only way you get an undefined slope is if you're dividing by 0. So here we have dy dx equals 2y over y squared minus 2x. What this means is that the denominator is equal to 0. So y squared equals 2x. So y squared over 2 equals x. So we're going to plug that in to the original problem. So 6 times y squared over 2 times y equals 2 plus y cubed. So here we have 6y squared over 2 times y. This becomes 3y cubed equals 2 plus y cubed. So we have 2y cubed equals 2. Y cubed equals 1, so y equals 1. So now that we've got that, now we have to plug this back in to here to see what x is. So x equals 1 squared over 2, which equals 1/2. So the point that we want is 1/2 comma 1. And then part D says the particle is moving along the curve. At the instant when the particle is at this point, its horizontal position is increasing at the rate of dx dt is 2/3 units per second. What's the value of dy dt? Now, focus that I tell my students is notice that this is in terms of t now. So both x and y are separate functions in terms of t, so we need to take the derivative completely again, this time with respect to t. Now we still have product rule in play, but when we do, we have dx dt and we have dy dt. But now, this is x right here, 1/2, this is y, -2, and this is dx dt right here, 2/3. So we have 6 times 2/3 times -2, 6 times 1/2 times dy dt equals 3 times -2 squared dy dt. All right, so 6 times 2/3 is 4. 4 times -2 is -8, plus 3 dy dt equals 2 squared is 4 times 3 is 12 dy dt. So when I bring the 3 over, 3 dy dt over to the other side, we get -8 equals 9 dy dt. So then that leaves us with dy dt equals -8 over 9. And there's our value. All right. Thanks for watching. I hope this helped. If you like it, check out all the other videos we've got on the channel.